Functions are an important part of almost every programming language. Functions allow us to group commands that we like to have executed together. We've already looked at using some of the built-in Matlab functions. Things like square root, sine, cosine, audio read, audio write, plot, and so on. However, as a programmer, we can also write our own user-generated functions and then put them to use in our programs just like the built-in functions. Typically, the way that this will work is we'll open up an M file and put the keyword function at the top of the M file, along with the name that we're going to give that function. And then we'll save it using that same exact name. If you're a musician, you can think of a function a lot like a guitar pedal or a software plugin. With a guitar pedal, typically we're going to plug some signal into that pedal and we'll get some signal out of that pedal. Then whatever effect it's going to create happens inside of that pedal. There might also be some knobs that are just some parameters as part of the effect. The same thing goes with functions. Typically, we're going to pass in some signals and parameters that we use as part of the commands within the function, and then we'll get some signal or information out of the function. There are several benefits of using functions. First off, it makes our code more readable. We don't have to have a long list of commands all in one script. We can break them up and put them into functions that have names that describe what the task is that they're going to do. It also makes our code more reusable. Think of it like having a plugin that you use in your digital audio workstation that you can instantiate in several different places as part of your session. Same thing goes with functions. We can write the code once and then reuse that in lots of different places in our program. So let's take a look at writing our own functions. First, let's revisit some of the concepts that we've looked at before in regards to working with scripts and built-in Matlab functions. This will make it easier for us to understand how things are going to work when we write our own functions. Let's say I have an M file with the name script1. If I wanted to execute these commands, I could press the run button. In this case, in the command window, I'll see the order of execution for A, B, and C. Additionally, I could type directly in the command window the name of the script. As long as that script exists in the current folder, it will execute this command just as if I press the run button. Press enter and see that I still get A, B, and C. The nice thing about this is that I can execute the script as a command in the command window, but also from within other scripts. So I'll clear this off and switch over. I have another script here called function script that's just going to be used to test other files. So as part of this script, let's say we have several things going on. We're going to have a variable here called x where we just assign it some variable. Then let's use the name of this script as a command. Now when I execute this, I can see what's taking place. First, we assign 20 to x, and then we perform the commands within script 1. If we want to see more clearly what's taking place, I'll set a breakpoint right here. Now when I run the script, I want to pause here, press step, and see that first 20 gets assigned to x, then I'll press step in. This will jump inside of the script 1 file and see that we've switched over from function script over to this one and continue on, A, B, and C. Now that we're done with this script, we'll switch back over to the other one. We'll continue on from there. So if I had another variable here, y gets assigned the value of 10, let's watch the order of things taking place. We start out in the function script, assign this variable, then we're going to jump over to script 1, perform these steps, jump back to the original one, and continue on from there. Down here in our command window, we can see the order in which these things take place. Another nice thing about this is we can call this script multiple times rather than having to copy and paste several lines of code each time we want to use them over here. Well, exit debug mode. and put in script 1 down below. Now what's going to happen is perform this command, everything inside of script 1, perform this command, and then do it all over again here. So first X, ABC, Y, and then ABC. So it makes our code reusable. Let's look at a few more things about the built-in Matlab functions. So I'm going to clear this off. We've used these before to perform different kinds of mathematical functions and also different things with audio. As an example, we have the square root function. I can put in here the square root of 25. So we have the name of the function, and we have parentheses that we use to pass in a number or a variable we can use as part of that function. So now we're getting the result, the answer of 5. We can also use different inputs. So I could put in a different number and it will give me the appropriate answer. So the square root of 36, you can see that we get a different answer. Besides just putting in numbers, we could also put in variables. Say x has a value of 81. You can take the square root of x. So this makes our code very useful, that we have a way that we can put in different kinds of input variables and our code will respond to that, or the built-in function will respond to that. If we just use these scripts as we were doing before, it does the same thing every time. But let's say we wanted to have it respond and put in one type of signal or put in one type of variable or a different type of number, get a different result. Last thing I'll say is that we can assign the output of a function. Instead of to answer, we could assign it to another variable y. So these are all things that we like to be able to implement in our own functions, where we have a name for it, we can reuse over and over again, we can pass in numbers, variables, signals, whatever it is. We can also get an output from that function that we can use for other things. All right, let's start a new script and look at what it takes to write our own function. So I'll clear this off. I'm going to open up a new M file here. When we declare that this is going to be a function file, we're going to use the keyword right at the beginning, the first line of the M file. We'll type in function. See that it changes to blue. After this, we're going to do several things. If we have any output variables, we're going to put the output variables in square brackets. So in this case, have one output variable. And then we'll put in the syntax is very similar to how we eventually end up using it. Let's just write our own version of the square root function so we can see how it's going to work. So I'm going to put in the name of the file here is user square root. This will be different than just using the built-in Matlab square root function. After we put in the name of it, we're going to use these parentheses. And within the parentheses, we'll put in any input variables like x. This is what we need to first create our function. If I were to go to save now, Command S, it's going to pull up and show that for the name of it, we're going to use the name of the function. This is very important. We need to have the name of the file match up with the name that we put here on the first line with our function declaration. Now, within this function, this is where we're going to put the commands that we want to get executed when this script is called. So here, I'm going to say y gets assigned x raised to the power of 1 divided by 2. So it's a way of calculating the square root without using the built-in square root function. I'm going to put a semicolon here. We don't need to print the output in this case. So I'll save this. Now I'll switch back over to my function script. This is where we can use this user square root function file now as part of other scripts. So here, let's start and just say we're going to calculate the user square root of 25. Now I'll run the script and see what happens. See down below that we've calculated an answer of 5. The nice thing is we can put in a different input variable of 36 and see that our function gives us the appropriate answer. We could also pass in a variable here. Say x is 81. Calculate the value of 9, or even assign it to a variable y. So in this case, our function now can respond whether we use numbers or variables, and it can also pass us back information that we can use. A few more things I want to mention about working with functions. In this case, I've used the same variable names here in my script as I have over here in my user square root file, but you don't necessarily have to do that. I'm going to switch this over and use A here. So A gets passed in, and we're going to receive B. Let me set a breakpoint and watch the flow of execution, what happens within this script, within the user square root script, and also over here in the workspace. So we'll start out. We're going to create this variable A. Let's assign the value of 81. Then we'll move on to this line. What happens here is when I step in, we jump over to the user square root file. Now we're going to use the input variable. It now has a name of x instead of a, and then we'll calculate this and pass the value of y back. So step, calculated that. We'll return back over to this function script and see that we now have a new variable b that has the value of 9. So it's okay if you use the same variable names, and it's also okay if you use different variable names. Let's watch what's happening in the workspace, because this is important too. So first, in our workspace, when I execute this command, we have a variable that's named A with a value of 81. When we step over to the user square root file, when we pass in the value of A, we get a different workspace. And initially, what happens is the variable that we pass in here of 81 gets assigned to x as part of our function declaration. Then we use x inside of this script for whatever else we want to calculate. So now in our workspace, we have a variable x and a variable y. When we're done, we're going to pass the variable y out of the function back to the other script and see that here we have our original workspace with the variables a and b. So that's several things about working with your own user-generated functions. Now we can create them ourselves and use them for many different audio applications.